having problems getting various AGI tools like Super AGI, Baby AGI, or godmode.space, any of these things sort of paying off with the kind of results that you know that they're capable of, but are struggling to get them, you're not alone. And I think a big part of it is that they have to solve a lot of the same problems, and there's no one easy way to do it. We've discovered a relatively new version of these, probably not AGI really, but these sort of agent tools. Microsoft recently dropped something called AutoGen. It was fairly quiet, but it's been started to be picked up by YouTube commentators all around the AI space, and I learned about it and started mucking in and playing with it and seeing what we could do. So let's have a little look at what that was, why that is more basic and thus exposes the problems for us that the other AGI tools are trying to solve. Gives us perhaps a bit more respect as to why it's a hard problem to solve, and where we can go next with our problem, our current business problem of trying to follow a relatively human-like lead enrichment flow, but having an agent do it automatically. So let's take a look. So first off, this is AutoGen. This is what Microsoft have put out there. It is basically a way of taking multiple large language model agents and having them talk to each other, and through conversations with each other come to resolutions sort of automatically. It can be used as a drop-in replacement for OpenAI, and it has a much better chance of getting to an outcome when it's probably going to need revisions. One of the examples, for example, is coding, where you want it to solve a coding problem, but there's probably some kind of relatively minor bug in the first output, and it will go through the iterations to resolve it before coming back to you and saying it thinks it's done. So that's really useful stuff. And I wanted to perhaps use this in place of where I tried to use Super AGI, thinking, okay, this will now solve those problems and make it work. But that's not what happened. So the project I was following along with to get into understanding how AutoGen works, rather than the very good examples in here in their GitHub, you can find that they have some Jupyter notebooks. But I saw this great channel here, Echo Hive, did a step-by-step guide which includes Patreon link and downloads for the code involved, and that code involved works as standalone Python files rather than Jupyter notebooks, and I wanted to work that way because that's how I was going to end up coding. So I thought let's go with this. He's also got a fantastic video that goes through it step by step. So I had the video open on one side and the VS Code open on the other. I'd gone through his instructions to get it all set up, and I was literally coding along with. And if you've ever done this for one of these demonstrations of AGI and you've hit problems that aren't there in the video, yeah, it happens. Here's what we had. So this version of the file is extremely simple. It's the most basic one. You see he's got 1 to 5 here, and the increase in complexity showing you what's possible with AutoGen. This one is extremely simple. You know, it imports into AutoGen, creates the assistant, creates the user proxy. So this one will carry on the conversation until it thinks it's come to a conclusion, and then talk to the user. And this one initiates the chat between the two, so the assistant and the user proxy, with this message: what date's today, what big tech stock has the largest year-to-date gain, and how much is it? Simple question. Something like Open Interpreter or Code Interpreter, or I think they changed the name, ChatGPT would be able to deal with it. So we want to do that to demonstrate it has the same capabilities. That's fine. This chunk I had to add. The reason I had to add this chunk, or specifically this one, is I had issues using Docker. I couldn't work out what was going on. Whenever I tried to get it to run, I had some issue. All of the Python code that the conversation came up with would execute properly, but all of the shell code that would try to execute didn't work. And so it kept trying to solve the problem, but of course it couldn't, and it was just going round and round and round in a loop. I discovered that if I didn't use Docker and allowed all of these files to be saved here locally rather than in their own container, then the problem went away. Don't know what the problem is. Maybe we'll work it out one day. For now, I just make sure you use Docker is set to false. It works for me. So this first one is really simple. You can see it starts with the conversation starter that we've written here, and then it starts doing sort of the kind of response you'd expect from ChatGPT. Here's a few steps. Here's some Python code. Here's what you'll need to do. So there's the shell command. You'll need to install yfinance, and then you'll need to do this. Now what happens is the user proxy says, fine, do it, and it pulls the code, executes the code, and returns the response to that assistant. What's really useful about that is there's probably an error in the first go. There usually is. It's great at coding, but there's usually some small error, and it needs to go through that. If you can automate those processes, that's great. So first thing that happens, I didn't interject with any input, so I just let it carry on with auto reply. This comes up all the time. Signal is not supported in Windows. It's no issue. And code output, today's date, got that. Collected the finance, it's done this is it installing the package that it wanted. And then when it executes Python, we get this issue here. It says, right, issue here on line 10, and it presents the error. But this is automatically presented back to the assistant agent. So the assistant agent immediately tries to resolve it. This is exactly what we want. This is great. So it says, in ChatGPT style, I apologize for the confusion. And then it presents an alternative that should fix it. Again, no human input. We let it carry on, and we've got a different issue. No symbol for FB. We happen to know that's changed to Meta, so I might have told that in a future one. Yeah, here we go. I saw this in an example actually within AutoGen. There was an example where the human provides input. I did the same. I noticed it was stuck here, and rather than just letting it carry on trying to solve it itself, I told it Facebook's become Meta, and then it's got it, understands it, and it carries on with code. No response. Go ahead and do the code. Downloads the price increase, calculates price increases, and tells me the greatest one. So it's done exactly what it wanted to do. It didn't take a great deal of information. The prompt was really simple, and I just hit enter until I knew I could help, and let it do it. So yeah, it worked fantastically. At least the basic one did after the Docker issue was resolved. The second one is a demonstration of some more conversations here, a little bit more complex setup. It's still fairly simple. It's going to ask what the date is, compare the year-to-date gain, and plot a chart, and save the file. And it's going to do that in its work directory, which is coding, which is made over here. So here was my result with this. We've gone through, got the code. It's given us a guide how to do it. Then it's given us some code. It's executed it. Now here's the first thing that I think is problematic. It's output a vast, it's got the correct date, but it's output a vast amount of data. And the way that I now understand AutoGen will work is that all this chat history goes into the continuation of the chat. It's a pretty big context to try and stuff in to the API call to GPT-4, and it could quickly swell larger than the context available. So it has a stock data and some code to deal with it. So now we've got quite a bit of code, quite a lot of stock data, a bit more code. There's an error that needed a fix, so it has to do some more. And then we get some sort of traceback issues. And when we come down to it, we get exactly the problem that we'd expect when we've got so much information to try and stuff into the context to send to OpenAI. The model's maximum context length is 8k tokens. However, the message resulted in 8,200. Please reduce the length of the messages, and failed. So this is because, unlike Super AGI or the other attempts at AGI, there's no built-in context simplification to try and mitigate this issue. AutoGen is very easy to use, but it relies on the developer to figure out how it's going to deal with knowledge retrieval and storage, how it's going to deal with context management. It's very naively, at least at the moment, as far as I understand it, very naively sends the entire chat through with each round of the conversation. So you need an external management of that to only have conversations that are short and targeted with just enough context they need to complete what they need. Almost like doing round-robin meetings. We'll have a meeting to resolve this handful of little issues with this description, and everyone talks and we get it resolved quickly. Great. Next meeting, we'll move on to the next issue, and it doesn't need to carry all of the information from the prior one. And there are some demonstrations of meetings between agents, genuinely, because that's what you can do, group chats, in this framework. So that's kind of what it's good at. But this was a demonstration file that I couldn't get to work because I hit this limitation. And it is a demonstration of the kind of things that go wrong when you're actually trying to do this quite cutting edge stuff. The third one is trying to solve a math problem. And it has basically some simultaneous equations to resolve, and then it goes ahead and does it. It also demonstrates saving the conversation to a JSON file. So this is my result with that one. We had read that out, it gave it a go, it knew that it would need this package, this Python package, and it installed it. Then there was an error, it resolved it, it put an exclamation mark here, don't know why, that caused an error, so it removed it, then it installed it. You can see the context is growing, and then it successfully installed what it wanted. There was the code to execute, I let it do it, and it came up with this rather long response in the end that the code comes up with. And it comes up with this these results. And yeah, well, there's two issues here. Firstly, the result is not the same result that the video got, so something has not gone quite right. The video comes up with the result a plus b plus c equals 0. That's what it comes up with. I didn't get that, so don't know what's happened there. It failed to save the conversation. If I open the conversation JSON, you see there's just blank, nothing went in. So frustrating when you want to follow along and actually the example just doesn't work. So yeah, if you're having these kinds of issues, you're not alone. It is part of the course at the moment. So the fourth one is looking at who should read this paper. This is interesting because it's going to have to go to the internet and scrape that information. I was interested in this because remember my application for this, I'm imagining, is to surf the internet for a couple of publicly available websites to try and gather contact information for leads. That's the current sort of business purpose for why we're looking into doing this. So I want to see how this works. Who should read this paper? This one was really good. It's a really simple prompt. It goes in, it gets beautiful soup, which is going to be able to scrape web data. It makes this Python, saves that file, executes it, brings out the abstract straight away, and then figures it out who should read it, and provides this list of various people who do it. They have professionals and operations, research and decision making, educators and students, enthusiasts in AI and machine learning. It's the AutoGen paper, by the way. That's that link. So it's really, really good that it works. It went and made a piece of code to scrape a website and successfully scraped it, found the information, summarized it, and presented it. Fantastic. I'll come back to why I think this may not be the best approach every time. But let's see how some of the other things fared first. So we have the fifth one, which is trying to call functions. So this is great. This is using OpenAI has the ability with their APIs to provide a subset of functions available. Send that with the conversation history and the current question or message to ChatGPT or GPT-4. And in the response, it can call a function with the proper code to do so that your calling application can make the call and then execute what comes back because what comes back should be compatible with the functions built into that program. So it defines them here. We have this Python function, we have this shell function, which is basically the functionality that it's already doing a different way. So it's interesting to see that they've chosen that. Could have chosen something more interesting, but that's what we've got. And in this Python code, they're defined as functions, so that if we get one of these function calls back from OpenAI, we can use it. And then it should do this. So use matplotlib to draw two agents chatting with each other with an example dialog and save the plot in a file too. It will send that along with this definition saying what local functions could be used to achieve that outcome. And what comes back should then be used. So here's what we got. Unfortunately, it's not directly possible to use matplotlib to draw agents having a conversation, as it's a library for 2D blocks of arrays. However, we can represent dialogue as a sequence of statements, so it's going to give it a go. Okay, so it's going to consider an example dialogue, and let me generate the plot for you. And here we go. It's performed the function call, it believes, and it's giving me the arguments that it wants to give to that function call. And then we've got an issue with it. There's no valid escape. So it suggested a change the arguments. We've got another unexpected character. So it's giving it a change, giving the arguments. This is all automatic, so I'm not having to press anything here. It's just carrying on until it believes that it succeeded in the task. Another unexpected character, and then it's going to do more. And no module named matplotlib. A good alternative could be to use an online Python notebook like Jupyter. Given these constraints, the task is impossible to carry out as requested. Right, so that's a fail. Again, in the example of the video, it worked. So inconsistent results are something you're going to have to expect when dealing with a large language model that is going to do some thinking and believe that it has or hasn't solved the problem, often in a different way to when you tried the last time. So yeah, unfortunately, this one's a fail. Nonetheless, it's obvious from doing these, trying all of these, where its strengths are and where its weaknesses are. So it does inform how you could successfully use AutoGen to automatically have backwards and forwards conversations to get to a result before then doing something with the result. Your calling application can make one call and it can go away, think about it, and come up with a response that it believes is good enough. And to do that automatically rather than having your main application having to also have the logic to keep asking and make sure it's getting what it needs, there's some real value in that. So yeah, that was interesting. So how do we therefore use this to solve our current business problem of finding and enriching leads? So I knocked up a quick one here, lead enrichment attempt. Copy and pasted some of this content. Most of this is sort of boilerplate for the purposes of this, other than defining a work directory, making sure we're not using Docker because I couldn't make that work. Keeping it as the same as I believe I took it off the web info version. And then I basically changed the message to see what it would do and how it would succeed. And I've changed it since I used it the first time, so I haven't actually run it with Selenium. I just said before everything other than that. So I said scrape the web page to produce a dictionary of all input labels and their respective values. This is a form that's been pre-filled. A form link that's been pre-filled with some of the information and some of it's not there yet. Basically what I wanted to do is I wanted to have a look at this pre-filled form, understand what's missing, go and try and find that information, try and put it in, and then submit the form. That would be the ideal automation. So scrape the web page to produce a dictionary of all the input labels and their values. I've used some sort of code speak to try and guide how it's going to do it in code. I didn't say use Selenium or ensure it's totally loaded or any of that. That became obvious afterwards because the initial HTML hasn't got everything all in the right place. It needs to run like it would in a browser before that's true. So I've added that. I haven't tested it. But what I did have is I did know that the input fields had this HTML attribute. that tells them where the label was. It's not like an old style web form where you have the label next to the input. It's not how Google Forms does it. So I had to add this detail. You see, you have to increment it to make these things work. So that's what we got to. Empty fields should still be present, but with null values. Create a JSON object and save it to a file. And it was pretty good for quite a simple first go. So let's come to this one. So let's create the web page to produce a dictionary. You can see it's quite a long URL. And yeah, so here we are. Empty fields should still be present. I didn't have the stuff about Selenium then, and we gave it a go, and it decided how it was going to do it. It was going to use request library, beautiful soup, like it did the other time. Gave me some Python code, and the steps to do what it was going to do, and it carried on doing it. I just kept hitting enter at this point to just let it carry on. Everything seemed reasonable. And it did a good job at attempting it. But of course, we're coming against the issue that the form isn't formatted in a way initially that it would be easy to extract those values back. So it definitely needs more iterations. But this was an extremely easy first go to try and get it to do something complicated. And it tried until it thought it was successful. But then again, this brings you the other problem. When it thinks it's successful, as the user, you may disagree. So it's not necessarily still a straightforward drop-in for OpenAI, go do this thing, and then the result may not actually be up to scratch. But yeah, this is definitely a great way of doing it to solve the problem the first time. The reason I say that is because it's become obvious through watching these backwards and forwards in these conversations and how context is managed and how the context can quickly grow too big that it's too wasteful for this to be the way you did it every time. It would be extremely wasteful for me to have a Python code that ran through the entire flow that we've decided is how lead enrichment should work, because it will try to solve the problems for new every time, and that's really not necessary. I want the special something that AI brings to the table when it's analyzing the difference between, let's say, the information you already know about a company and a website that you found in search results to tell whether they actually are the same company and whether you should trust those contact details. That's a specific LLM friendly task. If we organize the data effectively, it can do those comparisons. That's great. Using AI to help write the tools to enable me to do the whole process is great, but using AI to run the entire thing every time is going to be wasteful, not least because there are going to be so many API calls with ever-growing context that it could be quite expensive quite quickly. No, that's not going to be the way that it's going to work. So how are we going to solve it? Our test activity is now pretty well demonstrated in UML. It's pretty long. Its first draft, I think, covers all the bases. It's a fairly large item. This flow alone would fill a context. So I can't imagine a conversation that runs through each one and then keeps appending that detail to the next part of the conversation. I can't imagine that working. Now that I understand that the context is just going to grow with AutoGen, it's not going to be automatically truncated and managed at any point. That means I'm going to have to code something that shortens it, in which case maybe having an AGI of any kind running this thing from start to finish just isn't the right solution. It's sort of well defined already in terms of the automations. Only some of these steps, some of these decision points are good decision points for an AI to do rather than a human. And the rest, it's just code. I could use an AI to help write the code though, which is what I've decided is going to be the way forward. A little while back, I discovered this fantastic channel, Matthew Berman, and he had a great, a really good one on the best AI coder, and this is called Ada, and it does look absolutely fantastic. It is iterative and can work on a code base. So if you already have, for example, a Git repository full of a bunch of stuff that's sort of on the way to getting towards functionality you want, Ada is like pair programming. You can tell it how you need to amend it and it can deal with it. Really, really useful stuff. Going to be very powerful. I've seen I successfully made the snake game in that video with it. That is definitely how I want to do this. There is a way of doing iterative coding with AutoGen that I discovered, and I have to give a massive shout out to Andy and Ata in this one. There's discussion in the AutoGen Discord right now about this, and it looks like a really good idea. It takes some planning, it goes through iterations, but Ada already exists, so I'm probably going to go with that. Also, it will work with a Git repository, so I'll be able to track changes. It'll be probably easier to come back to it 3 months down the line when inevitably a website changes its shape and my scraping method fails and needs changing, and Ada can help do that. Although I might end up having AutoGen give at least a prototype for it, because that does seem to be useful. The way that Ada manages to work is really clever. It uses something called C tags to understand and interpret the definitions of the functions and the various bits and pieces within the repository. And that is the method by which it squishes down the context of that which is useful. So this has that part already built in. If you have a repository full of stuff, obviously that's too much to send straight through to an API. But if you can squish it right down to the things that matter, definitions of functions that you may need to call or use for GPT to use in the code that it comes up with, brilliant. And so this is how it does it with C tags. And so that's what we're going to do. We're going to now use Ada to create a first local massive Python series of code that can effectively do all of the steps in this monolith, and then if it goes wrong, we'll be able to use Ada to resolve what goes wrong, feed in the error message and change it. But by and large, most of the code that Ada helps to write will not be doing anything with AI. Only a few decision steps will therefore use an OpenAI API call to compare the relevant chunks of the website with the relevant chunks that we know about a lead to say, are they the same person? That's the way forward, because otherwise, if we tried to shove it all into an AI, it'd be extremely costly, or we'd have to code all of the context and memory management ourselves, and hard way forward. So that's the way we're doing things. Hope that's been interest, at least if you have also experienced pain trying to get AGIs working on your use cases. Maybe this issue is always having the right things in the context, and maybe that might help explain why it's a big challenge. Context is limited. Being able to understand where a flow is in the conversation is hard. And getting it to work for loads of different situations is also hard. Coding is one very specific kind of problem, but these AGIs are supposed to be just as capable of coming up with well-structured brand guidelines, for example. So it's not an easy problem to solve for a variety of use cases. And yes, newfound respect for the challenges that they're addressing with these attempts at AGI. That's it. Hopefully next time I'll have something interesting to say about how we've started to crack the problem of lead enrichment, how we've managed to make this work. I look forward to that. Hopefully soon. See you next time.